If you've ever bought something online, you've used an escrow, it's money held until a certain condition is met. I wanted to build that in Solidity, so I did. But in the process, I realized that the contract is flawed. That taught me even more than getting it to work. Some real-world examples of you using an escrow every day without even realizing it. A site like eBay, you deposit the money, they don't release the funds to the seller until shipment is confirmed. Airbnb, where the guest pays up front and the money is held until 24 hours after check-in, I think. And then freelance platforms like Fiverr and Upwork, the money gets deposited and doesn't get released until certain milestones are met. Let's get into it. So it's a basic escrow. We have a few variables: buyer, seller, amount deposited, and the deposit timestamp. There's 4 different states: created, locked, released, and refunded. So those, as we move through the contract, it'll just change the state into what state it's actually in. These events that will be emitted: deposited, released, refunded. This first constructor just initializes the contract with the seller's address. The buyer is set as the deployer of the contract, and the initial state is set to created. So buyer is the message sender, seller is the seller, current state, state.created. So this is just the initial state that it needs to be in. This modifier states that only the buyer can call the function to release the funds, which this leads me to a flaw in the contract later on, which I will go over. And then this next modifier just ensures that the contract is in a specific state before proceeding. Okay, the next function is the deposit function. It allows the buyer to deposit funds into the escrow, and only the buyer can deposit funds. Checks if it's greater than 0, updates the amount deposited, plus equals message value, gives a timestamp for when it was deposited, and then changes the current state to locked. As soon as the money's put into the account, boom, it's locked, and it can't be accessed until the buyer takes the action, and we'll go over that. The next function, release funds, allows buyer to release the funds to the seller. The contract state changes to released after the funds are released. External, only buyer, so that's the only buyer that can release these. If there's no funds, it'll give you the error, no funds to release. It then changes the state to released, stores the amount to be released, and then resets the deposited amount back to 0. Once it's released, it will transfer the funds to the seller and confirm. If it fails, it will give you this error, transfer failed. So the next thing we put into place is a refund function. This is an internal function to handle refunds. Internal state used to add cancel with timeout functionality. This function is called when the buyer requests a refund or cancels the escrow. So this just goes through, checks that there's actual money to be refunded, changes the state of the contract to refunded, stores the amount to be refunded, and then resets it back to 0 after it transfers the funds to the buyer, which is right here in this line: transfer funds to buyer, buyer.call value, and then gives you a success message. If not, it will fail and let you know, and then it will emit this refunded event. The final section of this contract is the refund functionality. First, we have an internal function, which is basically like the internal engine. So for the steps below, I don't have to keep repeating the same code over and over. So we created this refund function that makes sure that there's money to be refunded. It would change the state to refunded. It would store the amount to be refunded before it gets sent. And once it's sent, it would reset that back to 0. And then same thing down here. It emits an event and just confirms that it transferred to the buyer. And if it didn't, it would give you the transfer failed. So then this next section, which uses that function above, is function refund external. So this next section would be used once you implement this into a front end and use it with a website or your MetaMask wallet. This is what you would use for the buyer to interact with it outside of the contract. So that would be basically calling this function externally, and then it would put it into a locked state. And then this final one is cancel with timeout. It just gives the contract 30 days to go by before the buyer can cancel the agreement. So that's what it does in a nutshell. And then I did this whole testing suite with Foundry. I went over this in my last video, but basically you would do forge build. It compiles forge test, which then this will show all the tests that I did and that they passed. Okay, and then I will check forge coverage. This just checks how much of the contract we're covering. As you see, it looks pretty good. 14 out of 16 of the branches. So this is, everything's functionally working very well. To do the testing, I just used Anvil. I never actually deployed this to a test network or anything. I just used Anvil and got these default addresses from within Anvil, which is a tool set within Foundry. So even my ENV here is blank. I don't have any private keys. This was just a proof of concept to build my skills with Solidity. And this brings me to the flaws, which is what I realized after building this, because I'm going through it and I'm like, this whole contract is so heavily sided to the buyer. The seller has no benefits from this. So really this would never be deployed. There's also no delivery confirmation. There's no third-party arbiter. Basically, the buyer controls all the outcome. This was a good learning set, but I would have to advance it much more to get it production ready. Basically, if I was the seller, I would not want to use this from an unknown buyer, because there's nothing at this point stopping the buyer from just requesting a refund after 30 days, even after the service was provided. But it would still work if I built a little front end for it, and you could use it for a buyer that you trust or someone that you'd worked with before, and it was just a way to track your money in progress. Like say if you had a freelance project that you were working on and you wanted to hit certain milestones where you got paid in certain increments, you could use it for a digital product delivery. Once the product was delivered, it was a buyer that you trusted, boom, they would release the money. And yeah, it could just be used for peer-to-peer, like your friends. You could say, hey, I'll let this money go for you once XYZ is done. So all those real-world use cases that I mentioned earlier, like eBay, Airbnb, Fiverr, and Upwork, those could be put on-chain and done in this fashion, which is really cool. I'm not here to pretend I have all the answers. I'm here to learn, and this contract helped me understand what an escrow actually does and how it can go wrong. If you're learning too, let's build together. Drop an idea, fork the repo, which is listed down below, or just follow along on the journey and subscribe. Peace.